Hello everyone, welcome to this video. In the previous video we have studied about divergence of some vector quantity. So let me define it again for you. Suppose we wanted to calculate the divergence of vector v. Then divergence of vector v is defined to be when we take the dot product of the vector del by del x I cap plus del by del y j cap plus del by del z k cap dot with the vector v. Suppose its components are vx I cap plus vy j cap plus vz k cap. So when you take this dot product, you get a scalar quantity that would be del by del x of vx plus del by del y of vy plus del by del z of vz. So this is the quantity that you obtain, and you call this to be the divergence of the vector f v. Right, and we have also seen the physical significance for this vector v, physical significance of divergence of the vector v. So what does it tell you? The divergence of any vector v, where this, suppose v represents the velocity of the fluid. Now here the fluid, that may be some liquid quantity and it could also be air, right? So here the divergence of some vector v, this give you the rate at which the fluid is crossing the point per unit volume per unit time. So this we already have studied how we obtained this quantity, right? So remember, we draw this parallelepiped in the 3D space, something like this, right? And then we have calculated, suppose there was some point P here, so we have calculated what is the effect of some fluid which is crossing through this point P in this particular direction. So this we have already studied. So let's now define some other meanings for this thing. So let's see, say the vector v is flowing from the left hand side to the right hand side. So we'll see its effect on the point P. So we have these three cases. In the first case, if we obtain the divergence of the vector v, so if this quantity is positive, that means at the point P we would have the fluid something of this kind. So suppose the fluid would be moving out from this point at the point P, because here the divergence, say, that is a positive quantity. So the fluid will appear to come out from that particular point. Suppose this point is the point P. So in this case, we will say that the point P will act as a source. So that means from here the fluid will emerge out. So you can imagine the shower from which water comes out, so that can act as a source, or some other quantity, suppose the origin of a river, that is also a source, right? In the second case, whenever this quantity del of the vector v, this is a negative quantity, in that case at your point P the fluid will move into the direction of P. So that means we can say the fluid is going inside the point P whenever the divergence is less than 0. So we can say it is negative whenever the fluid is trying to get into the point P. So here the point P will act as a sink here, right? So you can imagine a situation, suppose there's some hole here and water is flowing in this direction. At this point suddenly water starts swirling like this and it is moving in and finally it goes into this particular hole, right? So what is happening here? The rotation movement that is given by curl, which we shall study further on. However, all of this fluid is getting inside this point P. So we can say here this point P act as a sink. And we have a third condition which describes no movement at all at the point P. So suppose the divergence of this vector V is exactly equal to 0. So that means we can say at the point P there is no loss or gain of fluid anywhere. Right? So we can say fluid is neither created nor destroyed at that point. So this thing is described by drawing like this. Suppose this is your point P. So here whatever is the fluid that is coming in, the same is going backwards. So whatever is coming in, the same is going backwards, and so on. So that means the overall effect here is nullifying each other. So we can say here no sources or no sinks are present. So in that case, we call, if that is so, if the del of some vector V is equal to 0, in that case we call, then we call the vector V as the solenoidal vector point function. So now you should remember this thing. So this is the definition for solenoidal vector point function. A vector point function where the divergence is of that particular vector is equal to 0. So that means in that case we can say we have a steady movement of fluid at that point. The fluid that can be water, some other liquid, or it could be gases. And moreover, in case of gases, we call this to be the incompressible flow. Incompressible fluid. So whenever we have this continuity equation, this equation is known as continuity equation. Whenever we have such kind of equation, the fluid is known as incompressible fluid. Right? So let us solve a question describing this. So the question says you are to determine the constant A such that vector V is given to be x plus 3y I cap plus y minus 2z j cap plus x plus az k cap, such that this vector is solenoidal in nature. Right? So this is very simple question. Now you know vector V is solenoidal whenever its divergence, so if its divergence is equal to 0. So that means we'll calculate the divergence of vector V here and we'll equate that equal to 0. So you know what is this del vector? That is del by del x I cap plus del by del y j cap plus del by del z k cap dot with the vector V. Vector V is defined to be this whole vector. So we have x plus 3y I cap plus y minus 2z j cap plus x minus az k cap. So when you perform this dot product, you will multiply the I terms together. So we have del by del x of x plus 3y. You will multiply the j terms together. So you have del by del y of y minus 2z. And then you will multiply the k terms together. So you have del by del z of x plus az. So now the next step is to perform this partial differentiation with respect to x first. So we will obtain 1. In this case, when you perform the partial differentiation with respect to y, again you will obtain 1, and in this case you obtain a. And we know this quantity is equal to 0, right? So this implies 2 plus a, this is equal to 0. So from here you obtain the value of a as minus 2, right? So this was very simple problem. Okay, that's it for this video. I'll be coming back with more problems in the next video. Thank you for watching.